January the 23rd, 2023. Guys, you're looking at information about close approaching asteroids to our planet. I had a question last night about a specific one. It's 2023 BU at the very bottom of the page in the orange bar. Now, the close approach data are missed distance. In the center is 0 LD, or less than 1 lunar distance. No lunar distance, as a matter of fact. You can see that that's the smallest on the chart. It has been for several years. They've been there, but they haven't listed them because of an argument. Actually, it goes back between me and the Jet Propulsion Laboratory years ago. I proved them wrong and they didn't like it. But here, January 26th, it's 0 LD. LD is a lunar distance. That's about 288,000 miles average. Now, let's look at the data. People are saying this thing's going to hit the planet. I think it's going to miss, but it could possibly take out some satellites. It's going to be that close, well under the satellite bands. At the bottom of the page, again, right here, your maximum minimum distance, nominal distance is 0.0007 astronomical units, AU, kilometers per second, 9.33, and that's very fast. We'll take a look at the breakdown on that information. But going back to the 0.0007 AU, astronomical units, 1 AU, is the distance between the Earth and the Sun, approximately 93 million miles. But guys, when you're dealing with that, let's convert this distance. That's very close to our planet. And well within, it's actually 20,000 miles under the DirecTV satellite band. Astronomical unit on the left, 0.0007, converted to miles, is 6,506 miles. Now, when you're dealing with the distance or close approach distance to any object, any planet, you go from the center of the planet. Now, guys, this is why I redid the video. I had to go in and redo this particular piece of math. Someone pointed it out, and I understood immediately what I'd done. Center of the Earth is 3,958 miles deep. We measure from the center as far as the approach or the close approach distance. That puts us at 3,958. Take that out of 6,506 miles from the center. We have the approach at 2,548 miles. That's 20,000 miles under the DirecTV satellites that are in the geostationary band, which geostationary means, as you see some satellites, especially like Starlink and all moving, geostationary satellites stayed right where they're at. They don't move. They're like a star because, again, that's a close approach. We don't know if the object's moving by itself or not. We won't know that until we get the radar images. Close approach is 6 a.m. Eastern Time on January 27th. 1:05 is UTC time. Kilometers per second, guys, is 21,698.3 miles per hour. That's 9.27 kilometers per second. So this thing's going to buzz in under the satellites, 18,000 miles under the satellites. And will we see anything happen? Now, if we go back to the Russian satellite at Chelyabinsk, guys, that was 18 meters. This particular rock is 5 meters, about 16 feet or so. Will it burn up? Possibly. It depends on, and if you listen to some of the other folks that know about this, the composition of the rock itself. Is it very hard steel, something else? If it's very hard steel, it can come in and make it through the burn through. But at 18 meters, again, a little over 3 times the size of Chelyabinsk's fireball, had a mass of 11,000 tons. In kilotons or TNT explosives, it was 440 kilotons. Remember, as it came through, it blew windows and buildings apart over Chelyabinsk, Russia. That was an amazing video. If you haven't seen it, you need to go check it out. But anyway, this thing is not supposed to hit the Earth. But if any of you guys ever listen to Mike from around the world, Thursday night he was talking about on Paul Begley's show, some of the asteroids contain ingredients that they don't want to come back down to the Earth. One of these satellites, the ingredients in it could do a lot of damage to our atmosphere. So again, we're diving in very close. Now, your space shuttle and things like that, you're only, 400 miles or so above the planet. Then direct TV satellites, 22,400. This thing's coming about 4,000 feet above our planet with an uncertainty of 6. Now, is it traveling alone? We have seen many asteroids that were not. They pick up one, and then when they come by, and the radars are catching them, you'll see multiple objects in there. One come by behind it, or it's towing something, just like a break. It's just like the asteroid belt. You could have multiple rocks. This is the one they're tracking, though, and it's not scheduled to hit our planet, like some are saying. When you see 0 LD, that almost puts it on the planet, but then you got to go in and look at take a deep dive into the astronomical unit distance and the speed. But it's going to come down, guys, from the left side, dip under our planet, and swing back. It's using the Earth as the ricochet, or the slingshot mechanism of its curve. But you can see that it comes around, guys, every year. And guys, if you want to check it for yourself, come over to our website at bpearthwatch.com and scroll down on the left, and you'll see this link, Space Weather. Click there. Now scroll down near the bottom of that page, and you'll see this chart that we were looking at the beginning of the video. Click right here on 2023 BU. Now, that's going to give you quite a bit of information here, as well as in the top left, an orbit diagram. But over on the right here, the solution date of this thing was January 23rd. The first orbit was 2 days ago. That's when they discovered this. Your condition code that I was talking about is orbit uncertainty estimate 0 to 9, with 0 being good and 9 highly uncertain. So we are at a 6 here. Again, the rest of the information's here that I used to get the data that we looked at in the video. And if we look at this chart, you can see it. And you can move this thing, or you can let it step automatic. But the sun's in the center, Mercury, Venus, and the purple line blue is in the aqua blue, then Mars is in the red. And right here in the white line is the asteroid. We'll have to zoom it up right there, 2023 BU. Right now, it's just behind the Earth in the outer orbit, and it will approach us in the next 3 days. Will be the close approach right there. Check that out. And then it will rise back up. You can see where it's coming in slightly below the ecliptic in the white line. That's what these rails are indicating. And then it's rising above the ecliptic and going to die back down. Now, again, the information is just a couple of days old when they found this thing. But what they do with that orbit, that arc span of data, they can go back and look at all the other orbits just from an arc. And it goes back to where you're going to see this thing get closer every year. But on all the data, as they traced it back, this is the closest approach so far, and will be for a long time. It goes into the past and into the future, the way the computers can take that arc, look at it, and give you this information. But it does not look like a direct hit, but it definitely will pass well under all the geostationary satellites such as DirecTV. Elon Musk now has 3,500 Starlink satellites up, plus thousands of others. So it's going to be a dive through that area. We'll just have to wait and see what happens. Will radar pick it up in time to give us any images? We don't know. It's moving pretty fast. But we're watching it, guys. You watch it. It's a heads up. Be safe.